Ready?
No. Yeah.
All right, go ahead and start.
Oh, yeah. Okay. Oh, sorry. All right. This is the Mathematics in Cats, and this is by me, Clarence, and Sarah J. And
Caitlin Winzenberg.
there we go. All right, let's get started. All right. So, with the history of cats, cats seem to always think they are above us, no matter what. If anybody has cats, you know what we're talking about. So, and they seem to think we amuse them. But that is not true. We actually have a very strong relationship with cats. Actually, cats have been friends with humans for about 12,000 years. Their domestication started in the Middle East, and cats were originally used for more like pest control, getting rid of mice and stuff. And yes, on here it says dogs are slobbering ignoramuses, but if you look at the note, it says that dogs are actually awesome.
She's a dog lover.
I am. I love dogs. All right. Another thing. Now, we think we are the greatest worshippers of cats, like the people of today. It was actually the Egyptians. They made statues of cats. They made giant sphinx of cats. It was just like cat country out there. There was actually a cat burial site filled with like 300,000 mummies of cats, and that was it. This is the reason. The reason for this is because of Bastet. She is a goddess of the Egyptian, goddess of love, and she had the head of a cat. Now, if you were to kill a cat in Egypt during this time, you would die. You would be beheaded, dead, gone. Ancient Rome was also a big cat lover nation. Well, not nation, you know what I mean. But cats were like a symbol of their liberty, and they protected their manuscripts. Next. Okay. Unfortunately, there were dark times for the cats. In medieval Europe, they thought cats were evil. They thought that cats were helping witches and the devil himself to conduct their evil black magic arts. It was quite awful. And cats were killed to ward off evil. Unfortunately, or ironically in their case, when they did kill the cats, this promoted the spread of rats, which carried the bubonic plague, which is basically Black Death. And millions of people died because of that. Karma for you.
Okay, so the history of the cat today. In present day, they're very famous and there are very many beloved cats. Cats such as Felix the Cat, Tom from Tom and Jerry, Garfield, Grumpy Cat, and the Nyan Cat are all very popular. So the math in cats. Today we will be discussing how they conserve angular momentum, the area of a two-dimensional picture of a cat using Riemann sums, the volume of a cat when rotated around the x-axis, and the velocity of a falling cat. Angular momentum. Its definition is a measure of the amount of rotation an object has with mass, speed, and shape. Its equation is L equals IW. L is the angular momentum, I is the moment of inertia, W is the angular velocity. W equals x over t, where x is the angular displacement in radians, and t, of course, is time.
Yeah, and there are several other equations for angular momentums.
Indeed.
Yes. All right, the history of angular momentum. All right, so it was first kind of based off of the laws of Sir Isaac Newton, who lived to be 84 years old. Oh my gosh, that's crazy. Anyway, so his laws implied linear momentum, and it's basically like a simplified version of angular momentum. It's just like P equals m times v, which is mass and velocity, equals the momentum of a particle.
Now, it may not look like it, but cats actually do follow the laws of physics. The steps on how cats conserve their angular momentum and land on their feet are as follows. A, they establish their position. B, they arch their back. C, they pull in their front legs and extend the back legs. D, they then flip over. E, they extend their legs and brace for impact.
It's surprisingly very hard to do.
Oh, I think
Oh,
it's the
there's
sound
another
on
one.
this. That's my bad.
It's okay.
Okay, the arch back ends up being pretty important. What he does is he divides his body up into two separate rotational axes that are tilted from one another. When he's released, he pulls his front paws in and does the accigator trick. He decreases his moment of inertia in the front so he can spin fast up there. But in the back, he pushes his legs away from him, increasing his moment of inertia. So a really large twist in the front equals a really small twist in the back in the opposite direction, and the torques equal out. So as soon as he gets his front paws in under him, all he has to do is extend those legs back out to increase that moment of inertia and stop the front twist, and extend his back legs along that rear axis. That allows him to twist those around really fast, and then all he has to do is pull them back in under his body, and then extend all four legs and brace for impact.
Yeah, so basically what you're saying, when a cat pulls in its legs, just like ice skaters, when they pull in their arms, they spin faster. So the cat can just zoom right over. Yeah, you're good.
Awesome. All right, so one of the, actually, two of the people who actually explained this a little bit more was Kane and Cher. They were at the Stanford University in California when they found this theory. They called it the dynamical explanation of the falling cat phenomenon, and it's basically this monograph right here. And basically, they didn't actually use cats for their experiments. They just took two cylinders, connected them at a single point to make sure it mimics the bend of a cat's spine. And they compared it to this picture of the cat, and they followed it down until landing. And,
Alright, so next we found the area of a 2D picture of a cat if it were falling. And this is a really rough estimate because we estimated like this would be 3.25, etc. And ran on some, we did the math, and it would be an over approximation, obviously, of all the extra blue area. And it should be cubed, but the area of the cat should approximately be 15.5 units squared if a cat were that size. And the history